My name is Casty, and today I'm just going to be showing you my YouTube project, and it's just over how cetus membrane produces pheromones that attract more Apiosphere to the seeds. Okay, so my little introduction. The Apis mellifera is also known as the typical honeybee. It comes from the genus family, which is just Apidia, which is just all the honey, which is just all bees. And then the species is Malfera, which is just honey, and that's just how it gets its name, honeybee. Honeybees are very important to the society, especially to the circle of life, because they have many different roles. Um, their pheromones produce as a defense response, and so it helps them just know where the danger is to defend their colony, and especially the queen bee, because that's a lot of their roles, is just to really defend the queen bee. The purpose of a bee sting is just a defense mechanism. So the sting warns off other bees of potential dangers, and then the bees will come to that site if they need to, and it will just help them warn off those people or just the predators. It could be big insects. It could be so many different things. And then it also is a place where they can seek pollen. And so they can smell those pheromones to see if the bee has seen any other place for a colony or seeked pollen for food. And so other bees can go to that site as well. So factors that cause a bee sting is so many different things. Like one of the biggest ones is just defense. And so, for example, scouts try to go find other places to create a colony once a different queen takes over that specific colony. And so because of that, they get into a lot of different situations where they see predators. And so they have to go and fight off the predators, and they warn other bees whether to go to that site and help fight off or whether to just stay and protect the queen bee in that colony. A pheromone is a chemical used for communications between two Apis mellifera. It also is used between many different species, but it's normally just the same species. Okay, the different parts of the Apis mellifera sting. The first one is the venom sac. So the venom sac is just what holds all the venom, and then the gland is what produces the venom. Pure venom is just a venom that is used in a sting, and so you can feel it when it's stinging. That's just what makes it hurt so much. The Coschuico gland, sorry, that's a really hard word to pronounce. That is a gland in the shaft of the bee sting, and it just produces the response pheromone for the other bees to smell. The cetos membrane is part of the stinging apparatus as well, which just has small hairs and it helps them release the pheromones faster. The Dufour gland is just around the stinging apparatus and it secretes the pheromones that they use for communication. So when they use communication and they communicate with the other bees, they use the Dufour gland because it just helps that communication and it produces the pheromone for that specific communication. And then the sting sheath is a flap that surrounds the sting and it helps the guide the stinger when attacking a predator. So when it stings us, it's just this sheath that helps it guide it and just protects it when it's not stinging anybody. And here's just diagrams of um the honeybee Apis mellifera apparatus. Here's like the venom gland and the venom sac and all of just the other things. Here's the sting sheath, the sting, and this is just a very good representation of what the venom apparatus, the sting apparatus looks like. Okay, my research question was what part of the Appius mellifera bee sting apparatus causes the bees to respond quicker and end more population? So in this experiment, this is how it was set up. The first compartment right here was just their way of they made sure that the bees were um, they were frozen, but they were still alive to where they could still produce a bee sting. And so here they mimicked air so that the bees would respond in a sting. And so they put the frozen bees in there, put air pressure, and it made the bees sting. And then this is just called the exposure and response area, and that's where they measured the production of the pheromone, and it's also where they measured to see how many would respond to that production of pheromone. This diagram just shows us what part of the apparatus had the most alarm percentage and the most attraction percentage, which we can see right here is the cetose membrane. It had way more alarm percentage and attraction percentage than all the other ones, like the um, Cosquinico gland had no alarm percentage, and so it just shows how much better the cetose membrane was. This is also another diagram that shows that. It shows just the different parts of the apparatus. So here's the cetose membrane and how much more it produced quality of um, percent of guard stinging and everything. And so you can just see in another area how much the cetose membrane produced more pheromones and attracted more bees than all the other places. Okay, so the result of this experiment just shows that the cetose membrane has and triggers more of a rapid response to pheromones. This is the structure that has the hairs, so it just helps the pheromones faster because it has an immediate reaction to of the hairs and it causes the immediate reaction to the nervous system. And so with the immediate reaction, the alarm pheromone goes off a lot quicker. And so other bees can come and find them a lot faster. The long-term impact of this finding is just being able to understand how we approach bees and their defense system. It also helps us understand in order to manage bees. So I know a lot of people are beekeepers because they like the honey, and so we want to know how much bees like to swarm, and so we want to know how fast they will send off pheromones and how fast they will respond. And so it is important to know that so you can either evacuate really quickly if you need to, or just being able to defend yourself. Thank you so much for my presentation, for listening to my presentation. Here are my reference sheets, and I also have the cited of everything that I used on my sheets in the bottom corners. So, thank you so much for listening, and I hope you have an amazing day.